Hi, I'm Guang, 30 years old, second year of Friends High School. So over here, the question we're looking at is about limits, alright? So we're going on with our methods of limits calculations. And at this part, we're having, so far, we have revised direct substitution and factorization, alright? But when we look at this question, at first when you try on your own, you might not be able to solve it. But actually, we could use at least 3 methods to solve this, alright? So I'm going to show you these 3 methods I have right now. Method 1. So method 1, of course, the first thing you would think of. And what is that first thing that you think of? Well, of course, you see cube and you see plus 1, and then you would think of just taking out z plus 1. Okay? So this, you could use this way, but you have to be aware later, right? So z plus 1 at first. Then, let's take a look at the next part that you have to multiply. So basically it is z squared. And here you have extra z squared, so you have to minus z, then plus 1. Right. So we're having this part right now. So we're having this part right now. Let's take a look. Usually when you use this way, usually when you see all the others, z plus 1 is one that making the 0, right? But wait, let's take a look at this part over here. Z plus 1. Z, what if you use e to the power of pi over 3i? So if you're using e to the power of pi over 3i, which will give you cosine pi over 3, which is 1 over 2. And I sine pi over 3, and sine pi over 3 would be square root 3 over 2. This part. So there's no way that this is 0. Since there's no way that this is 0, so that means the other part is 0. And by the way, this is the indeterminable form 0 over 0. Well, if you have realized that at first, good for you. So that means this part is 0. And that will mean we'll have to take out this 0 part from the denominator. But this could be simple, because since the denominator is also a multiple of 0, that means you could take it out easily. So you could use this long division. And also be aware of this long division. Usually here z to the power 4, and then here is z cubed, and then z squared, and then here you have a z, and then here plus 1. Alright? So you're going to have z squared minus z plus 1. So here you have z squared, and then you have z to the power of 4 minus z cubed, then you plus z squared. So when you subtract this part, you're going to get z cubed only. And since you're just going to get z cubed, this part you can add z. Thus you get z cubed minus z squared plus z. And this part you have z squared plus z plus 1, which at this part, wait, how is this a plus z? This is minus z. And thus here is plus 1. Here is z squared minus z plus 1. Right? So here you'll get z squared plus z plus 1. Right. So this is the part that you'll get. Another way, which is more simpler but more of logic. You first determine the first term and the last term. Then you see what the term in the middle could be by limiting it. Right? So I'll just erase this long division for now. So for this part, these two would cancel out. And thus you would be left with z plus 1 over z squared plus z plus 1. You could go ahead and do a small check, but this part isn't 0. So let's step inside and take a look. So z is what I worked out up here, which will be 3 over 2 plus square root 3 over 2i. Now, z squared, what you have e to the power of 2 pi over 3i. And e to the power of 2 pi over 3i, then you have cosine 2 pi over 3. And since cosine 2 pi, this 2 pi over 3 is in second determinant, second quadrant. And thus cosine would be negative. And you have negative half. And then plus I sine 2 pi over 3. But the second quadrant is for sine. Thus it will be plus. And this will be a plus root 3 over 2i. And then plus z. So plus z is what I worked out up here. So plus half plus root 3 over 2i. And then plus 1. Right. So at this part, you can move 2 down. So you get extra half. And here you have 3 plus root 3 then I. And then you have to over root 3i plus 1. Right, so this is the part that you're getting. Then you could times 1 minus root 3i on both sides. Thus you will get, here below is 4. And above, you have to times 1 minus root 3i. So 3 plus 3, 6. And then you have 2, negative 3, so minus 2 root 3i. And here you can simplify. And you get 3 over 4 minus root 3 over 4i. So here's the answer that you're getting for method 1. Next, we'll be checking with method 2. So method 2 from this part, it would seem a lot more simpler. Just to let you know, it will seem a lot more simpler. But at this part over here, what we will have to do is, you see the form of the denominator? Yes, in that form of the denominator, you could just take z squared as one variable. And if you still remember all those x squared plus x plus 1, all those, they times x minus 1, good for you, since we're using it here. And thus, this part you need to times z squared minus 1. And here is z cubed plus 1. And then z squared minus 1. Now just sit back and watch this miracle happen. So here you have limit z approaches e to the power of pi over 3i. Now this miracle over here, how does it happen? That means you only have z to the power of 6 minus 1 in the denominator. Right, z to the power of 6 minus 1 in the denominator. But wait, what did you realize from this part? You could use a squared minus b squared, which you're actually using factorization. And thus you have z squared minus 1 over z cubed minus 1. And from these two parts, what we're going to get, just sub them in. So z squared, as we have worked out just now, negative half plus root 3 over 2i, then minus 1. then over. So z cubed, when I work it out, is e to the power of pi I. So e to the power of pi I, cosine pi, well, I guess you know what that is. And sine pi, well, that's obvious enough. And thus in the denominator you have -2. And since you have this part, that means you're going to have, well, you could take out that negative, right? And yeah, or negative, you can just put it inside. And thus, you will get right? So you will get this part over here. And if you have realized it, so far, these two are the same. Right, so let me just record it at the side here that this answer is 3/4 minus root 3/4I. So this is what we got for the first two methods. Next, we'll move on to our method 3. So just erase this part over here. Alright, let's take a look at method 3. So method 3 over here, we are now touching more on complex variables, alright? So as we're touching more on complex variables, we have to take a look at some of these examples first. So from here, the simplest one would be z cubed plus 1. Wait, z cubed plus 1. Let's just let it be equal to 0 first. Since, wait, it is actually equal to 0. Okay, so this, you can just write it like this, right? Then you could solve it as an equation. Solving it as an equation, and you get z is equal to minus 1. Oh wait a second. Z is equal to minus 1 only. That means you only have one of these terms. That's not right. Z cubed, you're supposed to have 3 roots, but z is equal to -1. Well, so this is where that complex variable parts come in. So -1 is actually cosine pi plus I sine pi, as we have done just now. And thus this is e to the power of pi I. If this seems familiar to you, e to the power of pi I. Alright, e to the power of pi I. Wait, have you heard about 1 period, all those things? That means it's not only e to the power of pi I. You could also have, so 1 period, 2 pi. And thus you can move e to the power of 3 pi I. You can also move to e to the power of 5 pi I. And you can keep on continuing, right? Yeah, you can keep on continuing. But for this part, the only parts I'm going to use would be z is equal to e to the power of pi over 3 I. Then e to the power of pi I. And e to the power of 5 over 3 pi I. Wait, okay, we can still go on, right? Yeah, we still can go on. But wait, let's take a look. E to the power of 7 over 3 pi I. How about let's take out, seems like you can take out 2 pi. And if you take out 2 pi, you will get plus 1 over 3 pi I. And thus, this 2 pi is actually useless. And it goes back to 1 over 3 pi, or pi over 3. So we only need these 3 parts. Right, we only need these 3 parts. Okay. And thus, z cubed plus 1. would be equal to z minus e to the power of pi over 3I, z minus e to the power of pi I, and z minus e to the power of 5 over 3 pi I. So this is a part that you're going to get for z cubed plus 1. While the next part here, next part would be z to the power of 4 plus z squared plus 1, and since this is 0 over 0, which you have calculated by direct substitution. 0 over 0, this part is also 0. Wait a second. From the first method, we have been taking z squared as one variable, or I mean the second method, right? We're taking z squared as one variable. So we can do the same, and then we use quadratic formula, which will be negative b, in this case negative 1, then plus minus square root. So 1 minus 4ab, b squared minus 4ab, whereas all of them is 1, so it's 1 minus 4, and thus you'll get root 3I, and this will be over 2. Right? So this is your z squared. Z squared. This form seems familiar. We've seen it somewhere, right? So let's just take a look. Let's say if z1, 2, and this thing squared is negative 1 over 2, negative half plus root 3 over 2I. And let's say we have z3, 4 squared, and this is negative half minus root 3 over 2I. This seems extremely familiar. Did you realize that? Well, of course, it comes from all this formula. And this part is e to the power of. What do you expect this part? 2 over 3 pi and I. And this part, for both of them are negative, and thus is in the third quadrant for tangent and tangents. And so you get e to the power of. Is this correct? Not so. The correct one is 4 over 3 pi I. Well, just now I was just joking to see if you're really paying attention. If you have realized 5 over 3 pi I, well, that has become in the last quadrant, which cosine is now positive. Thus, that is not right. So for this part then, it gets a bit complicated. Z1. Or should I just write Z being equals to first one, positive e to the power of pi over 3I, because you need to square root it. And then negative e to the power of pi over 3I. And then positive e to the power of 2 pi over 3I. And then negative, so here is negative e to the power of 2 pi over 3I. There, these four, right? Yeah, correct, these four. So since you've already gotten these four, and that means z to the power of 4 plus z squared plus 1, this part will be z minus e to the power of pi over 3I, z plus e to the power of pi over 3I, and then z minus e to the power of 2 pi over 3I, and z plus e to the power of 2 pi over 3I. These four parts. So we are having these four parts. Right. Let's just sub it back for now. And so this part z cubed plus 1. Z cubed plus 1 is this part over here. Goes here. And then over. So this entire part over here. So you get these 4 parts. And for this part that makes it 0, if you realize it, you can cancel it out. So from this part that you're going to get, well, probably not enough space over there. And so for this part, minutes. And then from this part, z e to the power of pi over 3I. So z here we've already calculated it before. Then you have to subtract this part, and thus, wait, this part again. E to the power of pi I. That is a negative 1. A negative 1, then a negative again, plus 1. And z. Half plus root 3 over 2I. Right? And then this part behind 5 pi over 3I. So that means you'll have it all in the 3rd quadrant. So it's actually just writing from this part. Right? You're basically writing from this part. So, negative of this part. So, wait, I mean some other parts, right? So, 5 over 3. The one I wrote just now, when it's supposed to be 4 over 3 pi, I wrote it purposefully as 5 pi over 3. So this is in a 4th quadrant, and that means cosine is positive, and so you have to subtract half, whereas sine is negative. So plus root 3 over 2I. Right. So here, for the numerator, we're done. Then is the denominator. So for the denominator, z plus, so 2 of this part, and 2 of this part, you're just going to get 1 plus root 3I for the first one. Then the second one. The second one here is basically this part. So half plus root 3 over 2I. Here minus. Yep, minus. So now it becomes plus half minus square root 3 over 2I. Alright? And here we're going to get z plus e to the power of this thing. So it is basically root 3I. Right? And this part, it will be equal to weight, and there's no limit in front since we've already subbed it in. So this entire part will be equal to, here you go times 2, so times 2 on both numerator and denominator. And here you just already get square root of 3i. And square root of 3i can cancel out with this part, and here is basically 1. So the only part that you would have to find would be half, and here is square root 3 plus 3 over, and wait, there is I here, or 3 plus square root 3i, whichever you prefer. And here is 1 plus square root 3i. And so you could times 1 minus root 3i on both sides again. And when you times that, here is a 4. So it becomes over 8. And same thing when you times that, 1 6, then minus 2 root 3i. And thus you will get 3 over 4 minus square root 3 over 4i. And this is the same answer that you get for all those above. So it is right. And I'm just going to end this lesson here. Hope that you can understand. And thank you for your watching.